The interstellar object known as 3I/Atlas, officially designated C/2025 N1 Atlas, has increasingly captured global attention because it represents only the third confirmed interstellar comet ever observed entering our solar system. Its discovery on July 1, 2025, by the Atlas telescope in Chile immediately signaled the beginning of an astronomical event unlike most others in recent decades. Unlike the billions of objects that originated alongside the Sun during the early formation of the solar system, 3I/Atlas came from the vast, dark spaces between stars. That alone makes it extraordinary, but what followed? Its trajectory, physical characteristics, unexpected brightness variations, and the social media controversies surrounding it turned a scientific discovery into a full-blown cultural moment. Unlike the planets, minor planets, and long-period comets gravitationally bound to the Sun, 3I/Atlas travels on a hyperbolic path, which is the key signature of an object not native to our solar system. Its inbound velocity, approximately 68 kilometers per second, is far faster than typical solar system comets. Objects that originate here are accelerated primarily by the Sun's gravity, but interstellar objects arrive already moving at tremendous speeds due to gravitational interactions with stars and other masses in their home regions. Because its trajectory is hyperbolic rather than elliptical or parabolic, the comet will enter the solar system, swing around the Sun, and leave forever. It will never return, making the 2025 to 2026 observational window the only opportunity humanity will ever have to study it directly. Scientists estimate the nucleus of 3I/Atlas to be between 14 and 20 kilometers in diameter, making it unusually large compared to typical comets. To put its size into relatable terms, observers have repeatedly compared it to the scale of Manhattan Island in New York, a comparison that quickly spread across news outlets and social platforms. Its coma, the diffuse cloud of gas and dust surrounding the nucleus, has a reddish hue, likely caused by complex organic compounds such as tholins. These substances are known to form in extremely cold, radiation-rich environments, often on the surfaces of icy bodies orbiting far from stars. Their presence supports the idea that the comet wandered through interstellar space for countless millions of years, exposed to cosmic rays that gradually modified its surface chemistry. As 3I/Atlas approached the inner solar system, it began to exhibit behaviors that some online communities described as anomalous. A number of amateur commentators, and even a few well-known figures like Dr. Avi Loeb, pointed to slight deviations in its trajectory, irregular brightness changes, and other observational quirks as potential evidence that the object might be something more than just a natural comet. Loeb, known for his controversial interpretations of interstellar visitor Oumuamua, argued that the comet's unusual features warranted open-minded discussion, including the possibility, however speculative, that the object could be artificial or contain signs of extraterrestrial engineering. These claims were heavily circulated on platforms such as X, formerly Twitter, TikTok, and Reddit, where astronomical speculation often mixes with conspiracy-tinged excitement. However, mainstream astronomers and space science institutions have consistently emphasized that natural explanations fully account for the observed behavior. Comets are notoriously unpredictable, especially as they heat up while approaching the Sun, as frozen volatile materials inside them sublimate, transforming from ice to gas. They produce jets that can subtly push the comet in unexpected directions. These non-gravitational forces, caused by outgassing, have been known for decades to alter comet trajectories, sometimes dramatically. Photometric variations, too, are standard. Unevenly distributed ice, rotating nuclei, and fragmented dust plumes cause the brightness to fluctuate in ways that may appear strange to the untrained observer, but are entirely consistent with known comet physics. In other words, scientists argue that nothing observed so far requires extraordinary explanations. A central point of confusion that helped fuel the online rumors was the claim that 3I/Atlas would be hidden or covered up by space agencies during its closest passage to the Sun. Some social media posts insisted that NASA or other observatories would deliberately withhold images, implying secrecy or concealment. In reality, the comet's apparent disappearance was due to a perfectly predictable astronomical event: solar conjunction. On October 21, 2025, the comet passed behind the Sun from Earth's perspective, making it unobservable from ground-based telescopes and most space-based instruments because the Sun's intense light outshines everything near it. This happens regularly with planets, comets, and asteroids. Even Mars becomes temporarily invisible during conjunction periods. The geometry of the alignment made the object unobservable, not any intentional restriction. As soon as it moved away from the Sun's glare, it naturally became visible again. The moment many astronomers have anticipated occurs on October 29, 2025, when 3I/Atlas reaches its perihelion, the point in its path closest to the Sun. This approach happens at a distance of 1,356 astronomical units and at 11:36 Universal Time Coordinated, a time precisely calculated long in advance by orbital dynamics teams. Harvard astrophysicist Dr. Avi Loeb called this upcoming moment the acid test, not because he believes something mysterious will happen, but because perihelion is the period when a comet's physical properties reveal themselves most clearly. It is when outgassing peaks, structural stresses increase, brightness reaches extreme levels, and any fragmentation becomes evident. For scientists, perihelion is the most valuable time to observe how an interstellar object behaves under intense solar heating. For the public, however, the phrase acid test helped intensify the aura of drama surrounding the event, especially when paired with speculative commentary online. A widely shared post from the account Astronomy Vibes at Astronomy Vibes circulated the day before perihelion, reminding audiences that October 29th would be a significant milestone. The excitement was not unwarranted. After all, encounters with interstellar visitors are exceedingly rare. Before 3I/Atlas, the only two known interstellar objects were Oumuamua, discovered in 2017, and 2I/Borisov in 2019. Each of those encounters raised profound questions about the materials, structures, and histories of objects that formed around other stars. Due to the extreme distances between star systems, scientists have very few ways of studying extrasolar materials directly. An interstellar comet passing through our solar system provides a fleeting but precious opportunity. Every spectroscopic reading, image, and thermal measurement offers new insights into the chemistry and formation processes of distant planetary systems. Still, despite strong scientific interest, non-scientific narratives surrounding 3I/Atlas grew quickly, ranging from claims that the comet was unexpectedly slowing down, to predictions that it would reveal concealed technology, to theories that its visibility was being manipulated. Nearly all of these claims originated from misunderstandings of ordinary comet behavior, misinterpretations of public observation data, or speculative reinterpretations by individuals eager for extraordinary explanations. In contrast, observatories around the world, professional and amateur, have been openly sharing their data, including photometric measurements, orbital predictions, and high-resolution imaging. No evidence has emerged to contradict the natural comet model. When examined closely, the fluctuations that some online users described as trajectory shifts are simply the standard challenges of modeling an active comet. As more precise measurements are taken, orbital solutions are refined. Early estimates often shift slightly as better data becomes available, especially when an object comes from interstellar space and has never been tracked before. These refinements do not reflect spacecraft-like maneuvering or intentional direction changes, but rather improved modeling techniques, something that occurs with virtually every new comet discovery. Similarly, the unusual brightness spikes can be attributed to sudden outbursts of gas or dust, which are extremely common among active comets. These outbursts can make a comet brighten by large factors in short periods, especially when sunlight begins hitting fresh subsurface ice exposed by cracks or fragmentation events. What makes 3I/Atlas particularly fascinating is not that it behaves unlike other comets, but that it behaves exactly as an interstellar comet should. Its reddish coma, high velocity, hyperbolic orbit, and chemical signatures are all consistent with an object that formed around a distant star, drifted through interstellar space for millions of years, and is now making its only pass through our solar system before departing again into the cosmic void. Rather than being a controlled or technologically advanced craft, it appears to be a natural relic of planetary formation. One more piece in the enormous cosmic puzzle astronomers are trying to solve. As the comet approaches perihelion, global observatories are preparing to intensify their monitoring efforts. Once it emerges from solar conjunction and becomes visible again from Earth-based telescopes, astronomers expect a surge of new data. Amateur skywatchers, too, are standing by with small telescopes and imaging equipment, hoping to capture a rare visitor that no one alive today will ever see again. The excitement, speculation, and scientific anticipation all converge on the same moment: the comet's closest approach to the Sun. It represents not only a scientific milestone, but a reminder of how vast and interconnected the universe is, and how many mysteries remain to be discovered.